Hi, Mike.
Hi.
Um, how's things? Do you think it's going to only be the two of us?
Think so, yeah.
Right.
Srinivasan is traveling right now, so he won't be able to join us. But,
Yeah.
mhm.
So how are you getting on?
Yeah, it's quite heated up in India right now. The heat waves are quite high. So in
Really? Yeah.
in in yeah, the 43 degrees centigrade.
43?
Yeah,
Crazy.
yeah, it's crazy.
Have you got air conditioning?
Yeah, yeah. hmm
Yeah. I go on my holidays to Greece, and like if it gets up to about 35, it's like unbearable for me.
hmm
Obviously, because I'm from Ireland, it's like normally very cold and rainy, but and yeah, like I live in Manchester now, where it's equally rainy. So yeah. But yeah, I don't think I could stand that temperature. Would be too much for me.
Yeah.
Yeah. How are you getting on with the competition? Have you made any progress?
Yeah, I've been trying on those kernels that are publicly posted.
Yeah.
Yeah, I've been trying to understand those uh the approaches that they are trying to take. And I have still got to figure out those fine-tuning based approaches, but right now with the debutta and uh that sklearn based approaches that have IDF and uh, those ML based approaches. So those K nearest neighbors classifications and stuff. So I'm looking at those notebooks right now. The add
Oh.
the notebooks at the top, which are there.
Yeah. I haven't seen any K nearest neighbors one, but yeah, like I'd been working with the top notebooks. Yeah, just looking at all their pre-processing and stuff, which I think I understand all of that. But then there was one notebook. There was one notebook I think it's like sort of the second highest rated. And you know, like the highest rated one, it puts the output of its DeBerta model in as features into the LGBM. The one that was in
hmm
second place, it was putting in uh, the output from three DeBerta models. But like in its training thing, it was using the out of fold predictions from the main DeBerta model, but then in the inference, it was using the average of predictions from the three DeBerta models. Um, So I thought it'd be a good idea to, rather than using just the out of fold from one model, to produce like a set of out of fold results for all the training set for all the three models. So I did that and spent like ages on that and like lots of GPU time to do that. And then I came back the next day once I had like my out of fold predictions for the three models and discovered that the person who'd put the notebook up, they went and made their DeBerta training weights private. So it just destroyed the whole thing. It was basically just a complete waste of time because of the fact that their notebook no longer runs. So yeah, it was very annoying.
Ah. hmm
Yeah, so in the discussion, I was like, I got a bee in my bonnet about it. So I put in the discussion, like saying, I thought that Kaggle should, if somebody makes their notebook public, I don't think they should be allowed to, after a while, like change the accessibility of their data sets because it breaks everybody's
hmm
work. But
Yeah,
yeah,
true.
people downvoted me. Said that, oh, you should be allowed to make your stuff private if you want, but it's once you put it into the public sphere or whatever, and like people build on it and work on it, as soon as you make it private, yeah, you destroy everybody's work. And the only way to get around it is if you ever see like a notebook that you're using a lot, is to download the data sets out of it to make sure that those things don't happen. So this has happened to me in the past as well, where yeah, like say you've taken like a model and you got like an ensemble of sort of five public notebooks, and then suddenly the last time it was actually somebody just deleted their whole notebook, and so you like destroyed everybody's ensembles. But so I should have learned from my mistakes. Like after that, I started like always downloading the data sets and the notebooks. Where this time for quickness, I hadn't bothered, so I lost that. So I'm now having to retrain all the Deberta stuff myself. So
Oh, so you might have lost a lot of compute time too.
yeah, but basically it had taken me sort of like 8 hours of GPU time to run the inference on that Deberta thing to get the predictions to put in the training. As I say, like once I no longer had those weights, then it was all completely useless. So yeah, it was a bit of a pain. But yeah, so I'm back now. Yeah, so like Chris Diot had published a while back, yeah, like a sort of the simple sort of starter with Deberta Lite. So I've just taken that and just working on that a bit, trying to expand it a bit. And like as I say, I was going to try and get it to work with Deberta Large, but I had to. It wouldn't run on Kaggle, so I've had to take it over to Colab to see has it got enough memory to go through. I think it's like sort of what Srinivas was like saying last week. But because of that, yeah, I haven't really progressed other than trying to train the Deberta stuff. So I didn't see the K nearest neighbors things though.
No, it's nothing. It's just trying to uh, use that API and failing there to have a holistic view of what they were trying to represent. So K nearest neighbors is like a visualization algorithm. So that uh, uh, visualization was nothing. It 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 was kind of like failing. So it's like nothing to be uh, uh, nothing to talk about. Like so, yeah.
Right.
Mm-hmm.
The other thing I'd say was you like Chris Diot, he's published another notebook using SVR, which I'd seen he'd done it before in previous competitions. So I'm not sure is it any good, but yeah, I meant to have a look at it.
Mm-hmm.
Um, yeah, so like in that he just takes the vectors out of like a range of sort of different models, like such as Deberta Large, Deberta Light, and a few others or whatever. So it's actually you just like stick the training samples in, and you don't train the Deberta at all. You just take the vector out, and then sort of take the mean values from untrained models. I remember he did it before in another competition, and like actually, if you actually take a Deberta that's been trained on the competition, then you can boost the scores that way. So
Mm-hmm.
yeah, so that was one thing I was thinking of trying. Um, the other thing that I saw this week was again, I think it's in his SVR model. Yeah, so at the minute, because of the fact he's using like regression on his Deberta output, then he just like takes basic to get back from the regression values to get the category values. He just does like a basic sort of round to the nearest number type thing. Whereas like this time, what he's doing is he's defining sort of boundaries, and like like using sort of search techniques or whatever to find what are the best boundaries. So, for example, if you want to get for if you have like 2.4 as your output of your regression model, at the minute that would just like go to category 2. Whereas like if you put your boundary in, it might put it up to 3 and stuff. And so he says you get better results if you use those type of trained thresholds for each category.
Mm-hmm.
Yeah. You haven't tried also as well. Yeah, like this training data, it comes from like a larger data set. There's like another, I can't remember the, let me see, Yeah, it's called the Persuade 2.0 dataset, which contains like a load more essays that have actually been scored and stuff. So yeah, I was going to try that because of the fact that it expands the training set. Although I think within the training set, there's like sort of different categories of essays, and the ones in this competition are just from a subset of all the possible categories. But perhaps like a model that was trained on the whole thing first and then trained on the Kaggle data set, again, might get a boost from that.
So you're trying the Chris Jyoti's Deberta V3 small starter notebook, right?
What that's the base of, yeah. So I started with that, and then I'm trying to expand that. So as I say, I want to take it up to put a Deberta large into it. And plus as well, I'd seen before, do you know, what do you call it? AWP, or weight perturbation, or whatever it's called, adversarial weight perturbation. I've seen like in previous competitions, like, do you know, that feedback competition we did, people used it. It sort of is meant to like try and like help give you like a boost in your output just by jiggling the weights about, I think. So yeah, like at the minute I'm trying to run with that. But yeah, so the notebook I have that uses AWP with Deberta, it uses PyTorch Lightning. But yeah,
Okay.
PyTorch Lightning, it seems to keep changing all the time. It's like, yeah, so the notebook, it's like from version 1.8 of PyTorch Lightning, whereas they brought out PyTorch Lightning 2.0 and everything changed. And like, yeah, I find it hard to get the documentation for it. It seems to be most of the stuff's for Lightning before 2.0, and it's easy to find like loads and loads of notebooks that are from the old version and very few that are
So
from the new one. So
are you talking about this notebook?
which notebook, sorry?
I've shared my screen. You might
Oh yeah,
be looking at the pointer right
yeah.
now.
So that's the one that I based stuff on. So, but that one there, it uses Hugging Faces Trainer. Whereas, yeah, like as I say, I wanted to put the AWP weight perturbation thing in, and the example
Okay.
notebook I have of it is Lightning. So I've taken sort of the core bits out of that one you're looking at, and then yeah, just changed the training loop over to use Lightning.
Okay.
But yeah, like that's the basis of it. But as you see, like that there's just using Deberta Small. Yeah, so it gets pretty good results, this one. But yeah, like if you try and run that with Deberta Large on Kaggle, it runs out of GPU. So yeah, so as I say, because of the fact that that person removed their weights for their trained Deberta model, which was on a Deberta Large, yeah, I'm having to train my own one now.
Okay.
So yeah, so I'm hoping to get mine trained and then back to where I was at the start of the week. So yeah, rather than having just one Deberta going into the LGBM, yeah, like have several.
And you're using 5 folds, right?
Yep, at the minute.
Okay. So it's like you're using the large Deberta V3 large with 5 folds.
Yeah, well, I'm intending to. I haven't got that far yet.
Okay.
I'm still on Deberta Small, yeah, because obviously Deberta Small runs much faster, so it's easier to try stuff out with. But yeah, I think I've just finally got my notebook running now. So like if it runs okay, then I'll switch over to the large version.
So when they are trying to infer the tokenizer, what is the thing that they are trying to do? Because I think so the tokenizer is different for each model for like debutter v3 small, debutter v3 large. Each has matlab, I think so. They would have the same tokenizer, but here they are trying to take the tokenizer and load it in a form of I don't know what they're trying to do. So I was curious, what did you get from here?
I think I could be wrong, but I thought they all had the same tokenizer. Yeah, so like when you stick your sentence in, I think you get all the same tokens for deburrda small and deburrda large, but it's just, is it not, that deburrda large has way more weights in its model, and so yeah, it's been trained on a lot more stuff and there's more power for representation. But yeah, so yeah, it's just like taking one of the essays, converting it into a token, then sticking it through deburrda, and yeah, like training the deburrda so as it produces the score that the essay should
Yeah.
have.
Yeah, I think so too. They have the same tokenizer. All the versions of debutter
Yeah.
V3 have the same tokenizer, but what they're trying to do is trying to load that and function it with the data correlator, because in the data correlator and the trainer part, they are using a tokenizer here. So
Yeah, so I think
here.
the tokenizer is the same, but yeah, I think it's just that, yeah, the auto model for sequence classification.
Mhm.
Yeah, so I think it's just like trying to sort of train the output layers of that to get it to take the deburrda model's output and then produce the classification.
Mhm.
I'm not entirely sure why it's the model for sequence classification, saying he's turned it into like a regression problem. I'm not sure why it's not a auto model for regression, but I don't know. I don't know enough about deburrda to know what the difference is. Yeah, like if you go into the Hugging Face website and like look at auto model for sequence classification, there's like a load of other auto models for different things. So
Mhm.
I don't know which is which.
Yeah,
Um,
true.
um,
Other than that, I haven't been able to do much experimentation, but I have to do some fine-tuning part bits that I discussed with Srinivasan last time.
yeah,
So that bits, so I have to work on those stuff. But yeah, this sequence classification also sounds like a good approach to get a high score. So people have progress that I don't know what's the current leaderboard right now.
well, the highest
Uh,
public one, I'm not sure what the
it's
is.
8225.
All right, it's been that for like a week now. But yes,
Yeah.
see the one in fifth place there, the 822.
Hmm.
Yeah, so the highest public scoring model has 822, and like what it's done is, again, remember that the feedback competition, I think we talked about it last week, where you're getting your model to predict if it's how sort of concise. There was like the 6 categories essays were being given. So the person's taken like a model from that competition and used it as features, and it gives 822. So yeah, so I'm surprised that nobody's moved further away yet. So
Hmm.
yeah, so yeah, like everybody's bunched together, I think.
Hmm.
So yeah, but yeah, if you look at that, if you just click on Chris D up there in number 6, If you look at his code, that's probably
Now let me try to go back from here. Yeah.
yeah. So you see the third one down, the SVR starter. Yeah, so this is the one I was talking about. This is the one. I think he had a picture in it.
No, he doesn't have a picture right now.
Oh, I know what it is. I think he's got a link in here to a discussion topic. And does he not? Oh, yeah. So there.
Yeah. That's the discussion topic, I think. Yeah.
I'm not sure. He had a discussion specifically about this notebook, which has a picture in it that shows how it works. So it's not that one.
Okay.
Oh no, it's from that notebook, but yeah. So you see, like the last line of his paragraph about the thresholding. That's the stuff we were talking about, and yeah, I'm not sure.
Okay.
Yeah,
Okay.
but anyway, yeah, there's some discussion topic that he has or whatever. So if you just go from his sort of profile or whatever, you can find his discussion about it. Yeah, so that's all about the thresholding, like how you can get a reasonable boost by using it.
Maybe it's in the discussion, so I'll try to.
Oh yeah, if you just do SVR maybe.
So this is all the discussion channels that he has.
Oh yeah, that bottom
Rapids.
one. Yeah, I
Yeah.
think that's it. Yeah. Ah, there's
Yeah.
the picture there. Yeah.
Yeah.
Yeah, so like it explains what's going on in the notebook. Yeah, like how it's just taking the embeddings from each. You just like stick the test data into each one, and you don't even bother training them. You just like get the vector out, and then as long as you've got a sort of big enough pre-trained LLMs or whatever, you can get the vectors and use SVR to give you the prediction. But yeah, so I haven't tried this myself yet, but I know that we've used this before and it worked quite well. So yeah, so there's lots of stuff out there. I just need to get the time to try it all.
Yeah. So do you know what is this all about? I have no clue. I haven't looked at this. So if you can give me a brief rundown of what it is about.
Well, what's about this SVR thing?
Yeah.
Oh, yeah, like as I say, so you can see in this picture here. So yeah, so he hasn't trained any models as far as I'm aware. Yeah, so you can see there it says without any LLM training. So basically, he goes and takes just the, like, to start with on the left-hand side, the Deberta base. So he just like creates a Deberta base model with its like default weights. Then he sticks the test data through that, and then you get like your like embedding output, like your tokens. Um, and so he does that for, yeah, like in this case, 6 different models, all none of which have been trained on the data, but you just get like its basic sort of representation of what the test data is. And then SVR is like, it's just, yeah, like I think it just like sort of averages over the vectors. So you get like all the embeddings and it just like averages over them. Um, and then like you train that bit, you train the head. So you train it against the targets for the competition. So like against the essay scores. So you just like take all the vectors you see from each of the models, and it learns to see which of those vector combinations sort of matches for which score. And like in that way, then it can predict on the test set. So it is similar to, like the LSTM thing. Like in the LSTM, you're sticking all your features in. In this case, you're sticking vectors in. And then it's like, yeah, like learning which combinations of those vectors correspond with which scores for the competition.
Hey, it got disconnected. I think I lost my internet connection.
Oh yeah, I wondered what happened. I thought you might have
Yeah.
been thrown out. Yeah,
Yeah. I lost my internet connection.
it mustn't be able to stand the heat. Yeah, I'm not sure I've got much left to say on the competition. I think, yeah, as I say, I'm just
Yeah.
trying to get Bird models trained to replace the ones I lost, which I'm then going to stick back into the LSTM thing, not LSTM, the LGBM. And yeah, and then yeah, like try and take a look at sort of thresholding and that SVR thing, and yeah, like try and see if using the bigger data set helps. But yeah, I think it's just going to take a lot of GPU time to get there. So
what it's a machine learning framework or here?
sorry, I can't hear you. Your sound's breaking up.
Oh, I think so.
Yeah, I think it's okay now.
That might be due to okay. So it's a SVR is a specific technique or is it something else?
Sorry, what was that?
Uh, I think the voice is breaking out.
Yeah, your sound's just breaking up. I can't hear you.
Yeah.
Yeah, so should we leave it there? And then I'm not actually going to be here next week because it's the FA Cup final in England, so it's Manchester United against Manchester City, so I was going to be watching that.
Oh, okay.
But that's on next Saturday, yeah, so I'll be back the week after.
Okay, good. So, could you, just before the match starts, I think we will keep it short so you can join in and you can keep watching the match too if you're in the same room.
Yeah, so I just can't hear you, Mayank. It's just keeps cutting out.
Yeah, I think so. There's some issues with my internet connection here.
Right.
Get that sorted out.
Yep. All right. I'll head on then. So, I shall see you in a couple of weeks.
Okay. Oh, okay. Bye. Take care.
Okay. Cheers. Bye.